Stripe's AI agents now ship 1,300 pull requests per week. Zero human-written code. Human-reviewed, but not human-written. Every engineering leader I talk to has the same reaction. Should we be even doing this? And then immediately, what would it actually take? Here is the thing that most people miss. Every blog post about Stripe's system will focus on the tech, the agents, the tools, the architecture, but that's not the lesson. The real lesson is about how ready your code base already is, or isn't. I lead a 20-person dev team that ships with AI daily. Stripe's approach confirms exactly what we've learned and what most teams get wrong initially. 3 lessons from Stripe's system that apply to every engineering team, including yours. Here is the most important line from Stripe's blog post. What's good for humans, good for agents. Stripe runs their AI agents on the exact same infrastructure their human engineers use. Same dev boxes, same CI, same linters. They just had a really good infrastructure where the agents slotted right in. If your CI takes 45 minutes and fails randomly, that's not just painful for engineers, it's a complete blocker for agents. An agent that can't get fast feedback is just generating code and hoping. Every dollar you've invested in developer experience is now paying double. Fast CI, reliable tests, reproducible environments, that's not just making humans productive, that's the runway for agents. And if you haven't invested there, that's your first move. Not picking an AI tool, just fix the basics, fix the infra. So I usually ask 4 questions. Does your CI complete in under 10 minutes and pass reliably? Can you spin up an isolated dev environment in under a minute? Do your tests actually catch legit bugs? Are linters and formatters enforced automatically at every code edit? If you answer yes to all 4, you're closer to agent readiness than you think. If not, that's your roadmap, and it has nothing to do with AI. This infra audit is the first thing we run with teams at Team Brilliant. Are you agent ready? What needs fixing before you let AI write any code? So the infrastructure is the foundation, but here is what nobody's talking about. What happens to your engineers when AI starts writing all the code? At Stripe, engineers don't write code anymore. They dispatch, design, review the systems that govern how the code is written. And that sentence should make you uncomfortable because it changes everything about how you think about your team. Here is what it looks like in practice. Stripe engineers kick off multiple tasks in parallel via Slack. Each one runs in an isolated environment, writes the code, runs the tests and CI, and either ships a clean PR for a human to review or hands off to a human after 2 failed attempts at CI. The engineer's job is 3 things: defining the work, governing the system, and reviewing the output. Defining the work means writing in a format that machines can execute. Stripe uses what they call blueprints, step-by-step plans where some steps always happen the same way. Run CI or run a linter, and then some steps AI can figure out on its own, like fix this test failure or implement this feature. They also sync rules files across all of the available coding agents, Cursor, Claude Code, or their own minions. One set of instructions governs all of them. And here is what this looks like at your scale. Instead of assigning a Jira ticket to a developer who spends 3 days coding, you write the acceptance criteria and create an implementation plan and then dispatch it. The engineer who used to spend 3 days coding now spends 30 minutes shaping the work and then 30 minutes reviewing the output. Governing the system means teaching it. Every time the output doesn't match standards, the team updates rule files. The system gets smarter every week, not because the model got better, but because engineers improved the instructions. Verifying the output means reviewing PR. And here is the shift. When reviewing 1,000 PRs a week, you can't review code line by line. You verify the outcomes, not inspect code. Did it pass the test? Does it meet the acceptance criteria? Does it behave correctly? Now, apply this to your team. If your engineers stopped writing code tomorrow and started only shaping the work and dispatching it, what would break? And that gap is your transition plan. Start shifting now. Define the work in a format that agents can follow. Acceptance criteria, implementation plans, rule files. Build the review workflows that check for outcomes, not the code line by line. And train your team to orchestrate, not just execute. The teams that make this transition early will compound. The ones that wait will fall behind, not because of the AI, but because their engineers are still doing the work that should be automated. If you're seeing this shift on your team or you're figuring out how to start it, we do a free strategy calls where we dig into your specific situation. Link is in the description. So the infrastructure makes it possible, and the role shift of engineers is where the real leverage is. But none of it matters if you can't trust what comes out. Here is the question I hear from every engineering leader before they'll try any of this. What if it breaks something? It's a fair question, and the Stripe's answer isn't restrict everything. It's design the environment so nothing bad can happen. And that's a completely different approach. Restriction means you can only touch these X files, and that kills all of the value. Guardrails mean try anything you want in an environment where we know that nothing bad can happen. There are 4 things that Stripe does that you can copy. First, isolation. Every task runs in its own environment. No production access, no shared state. If something breaks, only that environment is affected. Your other systems are untouched. Second, bounded iteration. 2 CI attempts max. If the code doesn't pass after 2 rounds, a human has to take over. Stripe calls this diminishing marginal returns. More retries waste time without producing any quality. It's a simple rule, but a massive quality gate. I haven't seen this one before, so I'm definitely stealing it. Third, tool curation. Stripe has about 500 internal tools available, but each task gets only the subset that it needs. Enough autonomy to be useful, but not enough to cause any damage. Fourth, a human always merges. Always. No exceptions. Code gets written autonomously, but reviewed by human and merged by human. That's the final gate, and it's non-negotiable. Design this before you let agents write any code, not after your first incident, and you have a system that you can trust. The goal isn't controlling what AI does. It's about creating a world where you don't need to. And here is what Stripe's 1000 PRs per week actually teaches you. It's not about the agents, it's about 3 things. The infrastructure that was already in place before agents arrived. The role shift from writing code to orchestrating and verifying the output. And guardrail design that makes the whole thing trustworthy. Your dev infrastructure and developer experience is actually your AI strategy. And your engineer's next job is actually defining work and shaping it, and definitely not doing it. And trust comes from the environment design, not restrictions. If you're figuring out how to start it for your team, what infrastructure to fix first, how to shift your engineers' roles, how to design the guardrails that actually work, that's exactly what we do at Team Brilliant. Link is in the description. Now, Stripe proves what good infrastructure makes possible, but even with great infra, smart teams still get stuck for 3 specific reasons, and I broke those down here.